when you add carbon dioxide to the atmosphere, you heat the surface. We also know that that heating causes water vapor to evaporate. We boil off water, and water vapor itself is a greenhouse gas. And so what you actually get is a natural amplification of surface warming from carbon dioxide. And that warming is actually about twice as strong as the carbon dioxide effect alone.
Wow.
And so we wouldn't have a strong warming if we were on a perfectly dry planet. But we know there's this so-called water vapor feedback, an amplification really of the warming from carbon dioxide. There's all sorts of evidence it's happening, but one of the smoking gun, if you will, is that the upper part of the atmosphere, 5 or so kilometers above the surface, should start to be more moist. And so we think there's been a very slow moistening of the so-called middle and upper troposphere over the last 20 or so years. It's been very difficult to prove that conclusively. And so that's what I'm interested in right now, is trying to see the long-term trends in so-called upper tropospheric water vapor.
Fantastic. Tell me something else. I've heard that there's an inertia in the oceans.
Yes.
How does that work? How long is that period of inertia, and what are the feedback loops around that?
The oceans act like a gigantic flywheel. They hold huge amounts of heat, and for that matter, they release huge amounts of heat. And so most of the heat that's held in by carbon dioxide and other heat-trapping gases actually ends up in the ocean.